The latest release of HyperLynx brings significant improvements to the power integrity workflow. Starting off with the power network interface, it has been updated with several usability improvements for the user. Power networks are now displayed in groups that are consistent with the view that we see in the DC drop wizard. They can be expanded and collapsed individually. The net enable column is now sortable by clicking on the column header. And we've added a right-click menu option for assigning the root voltage of a net to other subnets directly from within the power supply net's view. Double-clicking a row header will zoom into the corresponding power net in the board view. And finally, in the power network topology view, VRM pins are now collapsed by default and shown with the VRM name and total pin count. They can be expanded if necessary to view the underlying pins associated with the VRM. And ICs without any assigned models are also auto-collapsed to reduce visual clutter. DC drop simulation results can now be displayed directly within the power network view. Voltage drop as well as power loss are displayed per IC that has a DC current sink model assigned. The results are color-coded, with red indicating a failure against the constraint and green indicating a passing value. Orange means that the results are out of date and a new simulation is needed to reflect the latest changes. Finally, the VRM nodes show the output voltage and the total current for the given supply rail. Moving on to the Power Integrity Models dialog, two improvements have been made. On the IC tab, we have a new option called Include Attached Nets. This shows all reference designators connected to the current power network setup selected. This makes it easier to view and manage power integrity model assignments across a full power network. Second, on the Other Supply Nets Components tab, filtering options for pin and net name have been added. This is particularly useful for quickly locating specific pins on large ICs with many possible connections. Several usability improvements have been made to both interactive and the batch DC drop workflows. We've added a setup summary option to perform an audit and confirm that all required models are defined before running a simulation. The summary table shows key information like the simulated net, reference nets, VRM information, as well as series passive devices. And the sync current for individual ICs is shown in a bar graph format below. Session file saving allows users to now save and reload their settings files in the session file option with load and save buttons. There's a new option called Keep Nets Highlighted on Exit. This option maintains net highlighting in the BoardSim workspace when we exit the DC drop dialog. And a single simulation can now generate multiple report types, including HTML, XLS, and CSV formats. HTML reports can also generate a PDF format. The DC Drop Shared Return Wizard also shares these improvements to the report format options. We have the ability to generate multiple different report types, HTML, XLS, and CSV. Another notable enhancement to the shared return analysis is we've significantly improved the simulation performance when simulating with multiple power supplies that are configured using multi-phase VRMs. HyperLynx also introduces a new metrics viewer called the DC Drop DC Metrics. This is integrated directly within the post layout environment, and the viewer opens up automatically in a new tab after simulation, or it can be launched manually via the Power Integrity Add DC Metrics View option in the command bar. It displays the key metrics including voltage drop, current, as well as power density, and via current throughout the power structure. And users can toggle the visibility of the board outline, pins and vias, and pin name labels for a cleaner view. Hovering the cursor over the board shows dynamic detailed information for that location. We also have adjustable thresholds for pass-fail evaluation. The last enhancement to DC Drop is in regards to the DC Drop app in the HyperLynx Advanced Solvers. The DC Drop app now supports a pin group assignment option for DC sync models. The DC sync type parameter now has 3 different options per pin, whole array, and new pin group option. With the pin group option selected, the sync current value that's specified is applied to the entire PI pin group. The IC pins are treated as equipotential, while current is distributed to each pin based on the resistance matrix at the PDN. This provides a more accurate representation of current distribution compared to the per pin and whole array current sync assignment methods. Back in HyperLynx Board Sim, there's been improvements to the decoupling analysis workflow. The decoupling wizard report has been updated with 2 new additions. A setup summary table is now included in the report, showing key design and simulation setup information for better traceability and review. And new impedance plots have been updated, including both the self-impedance as well as the transfer impedance plotted versus frequency. Labels are shown for each port that's analyzed. And these plots make it easier to evaluate PDN performance against target impedance directly from the report that's generated.